Hi, hi, good evening, everyone. Can you hear me? Is it audible to everyone? Yeah, good evening, everyone. Yes, sorry for delay. So before understanding today's concepts, let's try to recollect it what we were understanding. Yeah, so in the last section where we were going through that about VPC creation. In that VPC creation, yes, understanding that the first yes VPC with the CADR option. um, the creating that VPC with the CADR as that but CADR we are planning is nothing but that should be on the base of subnets, and in that subnets like number of devices point of view we need to yes plan it, the CADR. Yeah, that is VPC, the first creation. And after creating the VPC, yes, how many subnets that is required, and in which availability zone those subnets required. Yes, identifying about it and creating the subnets. But subnet creation is nothing but it is just like CADR allocating that. Yeah, from that VPC, what are the CADR we have, we can take it and we can allocate that the number of devices in each subnet. Yeah, we are creating that the two subnets, two, not only two, four, two for the public subnets and two for the private subnet in the different availability zones. Yeah, the creating the subnets. But you are creating a subnet is nothing but that should be defined with VPC and CADR block. How many number of devices that is required from the VPC. Yeah, after defining the subnets, then we were defining that internet gateway. But what is the purpose of internet gateway is that helps about it. All the network communications from that external to that. Yeah, so all that like internet communications which are required from that external, which we can get into that, or which we can have this all the communications by configuring that internet gateway. And internet gateway should be associated to that VPC, as we're talking about it, one VPC, one internet gateway, or one internet gateway to that one VPC. Yeah, mapping about it VPC with the internet gateway. But by just defining that internet gateway, we don't get that internet communications to the subnets, especially public subnets. Then what do we need to do this is we need to define a routing table. Yeah, the routing table configuration. Yeah, that helps about it mapping about routing from the internet gateway to the backend, the public subnet. Yeah, which are all the subnets that we are planning as a public. Those public subnets we define this in the routing table, routing from the internet gateway. Yeah, that's we were configuring that. There is separate routing table for the public and separate routing table for the private subnets. But private subnets, how do we get that internet is? Yeah, how do we get that internet to that the private subnet is? We need to define that NAT gateways. The internet gateway, that is to have it public network directly, which we use it for the public subnets. But we define that the NAT gateway to have that internet to the private subnets. Yeah, while creating the NAT gateway should be placed or should be created within the public subnet. So now this NAT gateway is going to use it the internet gateway, that net communications. Then through the NAT gateway, we need to map into that. I mean, to get that internet to, we need to map into that private subnets. But how to map it is, yes, we create separate routing table, mapping about the NAT gateway, all the communication mapping to the private subnets. Then what are the instances which you're creating in the private subnet? Those instances are going to have the net communications. Yeah, so that's we were defining, and but directly this instance which are created in the private subnet, we don't have any public IP address. Then what we were doing this is we were logging to this public instance. Yeah, the instance which has been launched in the public subnet, and from here to here we are internally connecting that. As these two are in that same network, yes, public and private subnets are in that same VPC, then those are local to each other. Yes, the resources which are in the public subnet can communicate with the private subnets. So we were logging to the public subnet EC2 instance, then we are connecting to that private subnet EC2 instance. But EC2 instance, is it getting that net or not? Yes, that is getting that internet. That is how it is getting this is through this routing table where we have mapped with the NAT gateway. Yeah, this was the thing that which we are doing that in the last section. Yes, have we done that? That's activity. Anyone? Anyone tried it to complete that? That's the creating all these resources. Yeah. Okay. Yeah. Please work it on it. There's a practically also, so that would be helpful. Yeah, coming to that, the one small concept on the networking side, which we should know that the difference between NACL and security group. Yeah, initially, if you just observe that the diagram which you are defining that, yes, NACL, so that is this is one kind of the firewall before entering into that the subnets. So that firewall the which works is evaluating about it all the rules, and once the rules have been the evaluated and the request if it is allowed, then it enter into it. I mean, then that request which will be allowed to enter into the subnet. But within the subnet, the EC2 instance are the RDS instance which are asking about it. Then again, the instance level we have the firewall, that is security groups. Yeah, the security group, again, it is going to evaluate it before entering into the EC2 instance. If the security group is allowed, then the request which will be entering to that for the particular service to the EC2 instance. But what is the difference between NACL and security group? Yeah, if you conclude it, that's one concept that which we should know that whenever we are managing about that networking components. Yeah, network ACLs and security groups for the incoming request. Yes, incoming request is like yeah, the first networking level, NACL, which is going to evaluating that all the inbound rules which have been defined. If that inbound rules are evaluated successfully, then it enter into that subnet. Yeah, in the subnet, like what of the EC2 we have, that EC2 instance that is going to evaluate the security group rules. And if the security group rules are evaluated successfully, then it process the request. And after processing the request, then outbound. So here the point what we have this is, suppose for the security group inbound rule, if you define that, what of that inbound rule that will be automatically applied to that outbound as well as. So here the point is security group point of view, inbound rule, whatever you have configured, that will be automatically applied to that outbound. You don't need to separately define that outbound rules. But NACL point of view, inbound rules, we need to define it, and as well as outbound rule also has to be allowed. Then only the request which will be sent back to the client. Yeah, that's why we say that security groups are stateful. That means if we define this inbound, then automatically that will be applied. Suppose particular service from the particular CADR, you are allowing that in the inbound rules is nothing but for the same port on the same CADR, which will be allowed for the outbound as well. That's why we say this one is stateful. But if you are defining this in the inbound rule for this NACL, then obviously we need to go for the defining that outbound as well as inbound rules are the different and outbound rules are different. If you define inbound, automatically that won't be applied in the outbound if it is NACL. That's why we say this is the stateless. Suppose if you'd like to understand these concepts, let me go to that. Let's let me log into the AWS console. Yeah, so here NACL, if you just observe that access control list, the network ACLs and security groups. NACL's point of view, if you observe that, suppose you are creating that any network ACL. Suppose let me talk it. This one is something demo, and in which VPC do you want to apply this NACL? Yes. Now the previous the demo whatever I have created. The VPC that's I deleted. Let me take it the default one. And if I create this one, NACL, and if you go for observing the rules, yes, here inbound rules are available and outbound rules are available. Yes, if we edit this, view details, let me go to this. Here you can see that inbound rules and outbound rules, even for the security group is also the same thing, inbound and outbound. But if you observe here, the comparison of security groups and NACLs, so here you can see the deny rules also. Yes, you can define the deny also. Suppose we know that some hacker IP address, and from that IP address, what are the requests which are receiving that we should deny it. Yes, on the particular IP address, what are the requests which are receiving to that network, we should deny it. Deny rule we cannot apply on the security group, right? Security group by default that is denied. Even that here also by default it is denied. You see that? So there's a rule number, the type, all traffic, protocol, all the protocols, and all the ports from all the IP addresses, it is denied. This is the default behavior. But if you would like to add that, yes, the rules for incoming, you can define allow rule and a deny rule. Suppose only the particular IP address. Okay, so this is like IP address which we have. Yes, or any IP address on the port which is receiving that 80, a rule number something. It should be multiplication of The 100 that is recommended. But what is this rule number? Will come back. Yeah, you have defined one rule number with a custom TCP and for the port 80 from any source. Now we are defining allow rule. Okay, so if you define this allow rule, yeah, now it is allowing that any internet or any all IP addresses, that is the meaning, right? All the IP addresses, that is allowing that. But you know that specific CADR where we should not allow that. Yes, you can define that the rule, that is something a rule number next to 200 and which is on the port number 80, the same we are defining that 80, but 10 something 0 dot the 1.0/16. That means from this CADR, any request which are receiving that, we should not allow that. Yes, you can define the deny rule also. Yeah, here we are allowing that any IP address, but from that, yes, if the source of IP address which is having this particular IP address, then we can deny that. Yes, we can define allow and deny rules, but whenever the request comes, yeah, the first it verifies that now here with the same condition, that is a port number 80, that we have this like allow and deny. The first it is going to apply that. Yes, that's the checking about the source IP address. If it is matched with this CDR, then it will be denied, or otherwise it will be allowed on this particular port number only. Remaining ports anyway that will be denied. But if you allow this one, that's inbound, outbound by default it doesn't take that, allowing that. That is in NACL. So if you define this inbound any rule, that is allow rule especially. Anyway, by default that is denied, right? In the outbound. Yeah, if you define this any allow rule in the inbound, that won't be applied directly for that outbound. Outbound also we need to define it separately. So even if you define this inbound also, when our request is going out from the IP address, it won't be allowed, because that is by default all IP address and with the destinations, that is a deny. Again, you need to add the rule here also for that 100 for the port 80, and whatever the CDR we have the destination. Yes, we need to define allow rule in the outbound also. Yeah, this is inbound and this is outbound. If you are defining this any inbound rule, especially for allow, make sure about it the same. I mean, if it is required like outbound for it, yes, the same rule you need to define that's in the outbound also. That is important. But in the security groups, yes, if you go to the security groups, so whenever we define there's any inbound rule, yeah, this is also VPC scope. Yes, in which VPC that's do you want to launch it? Anyway, we have this only one VPC. Suppose, yeah, if I have created about the security group, default behavior is let's observe the security group now. For the inbound rules, yes, we don't see this any deny rule. That means by default it is denied, right? Here we don't have that option any allow or deny. We have that the only if you're defining any rule is nothing but that is a allow rule. You don't have this any do you want to deny it or allow it? No, we don't have that option in the security group. But in the NACL that is available. So in the security group by default that is denied. So you are defining any rule is nothing but this is the allow rule. okay, we need to allow that on the port 80, the requests which are coming that from any CADR. Yes, if you need it, yes, you have the only allow rule. But if you define this allow rule, automatically this will be applied to that outbound also. You don't need to define that explicitly about this rule, that is 80 allowing that from any IP address. You don't need to define this outbound. By default, anyway, outbound is allowing that, all traffic that is allowing that. Even if you remove this rule also, for this, the kind of, 80 port, whatever we are defining that inbound rule, that is automatically which will be applied to that outbound. Yes, inbound, if we define that in the security group, automatically that will be applied to the outbound. But in the NACL, inbound is different and outbound rules are different. So that's why we are saying about it here, the statement that is, so inbound rules and outbound rules should be defined separately. That's why we say that this is the stateless. And here in the security group level, inbound, if we define that, automatically that will be applied to that outbound. That's, we say, the stateful. Yeah, that is the main point, understanding that. Yes, even that, like an outgoing request, if we just talk it that. Yeah, security group outbound rules and NACL outbound rules. And here also the same point, the inbound, if it is allowed, automatically outbound allowed. But here inbound and outbounds are the different. Finally, if we just conclude about that network ACLs, NACL are like as a firewall which control traffic from and to subnet. That is a subnet level. And a default NACL, that means whenever we create a VPC, we get it one default NACL that allows everything outbound and everything inbound. Yes, whenever we create a VPC, we get that one default NACL to that VPC. So that is that allows everything outbound and everything inbound. So one NACL per subnet, and new subnets are assigned to the default NACL. Yes, so whenever we are creating the subnet, yeah, so for the subnet, like one NACL, one subnet, we go for it. But a new subnets, whatever you are creating, that by default, that will be applied to the default NACL. And whenever we are defining that NACL rules, yeah, rules have a number. As we are observing that rule is having the number, right? Thus, we can define that 1 to yes, 32,766 up to that. But recommended is multiples of 100. We will manage it, or you can manage it 1, 2, 3, 4 also. And higher precedence with a lower number. Yes, whatever the lower number which we have, that is going to have the higher precedence. Suppose if I define the same rule, suppose here in the NACL, so here we have defined that on the port 8080, but sources that is different. Like suppose here you have defined with the same rule, with the yeah, the same rule, that is allow or deny for the same the port and same sources if we define it. So which rule is going to executing that the higher precedence is going to give, that is a lower number. That means 100, which will be giving that higher precedence than 200. The lowest number, the rule which is having that. So which is suppose here you have mapped with that 8080 and the source is also same and allow and deny. But one number which is 100 and second one is 200. So which one is going to allow executing that by NACL? So lower precedence which is having that 100, this rule will be executing, and as per this which will be deciding about it, allowing or denying that. Yeah, so the rule numbers, whenever we are assigning that, the higher precedence with a lower number. Suppose if we define that number 100 allow for the IP address and number 200 for the deny with the IP address. So IP will be allowed as we have that 100 is the lowest number, and which is defined that allow rule on that IP address, that will be allowed. Yeah, last rule is an asterisk. Suppose the request which is received, but it is not applied to that any rule. Suppose so-and-so IP address has been received, but we didn't define that IP address in the source. Then what it is going to do, this or which rule it is going to apply, that is, so it is going to apply that as an asterisk, that means other rule, and denies a request in case of no rule is matched. Yes, for that IP address, for that particular service, if there is no rule is defined, then it is going to, I am marking like as a denying that the request. Yeah, AWS recommends adding the rules by increment of 100. Yes, 100, 200, 300. So that is recommended. Newly created NACL will be deny everything. Yeah, just we are observing that whatever that the NACL which you have created, that is everything denying that for inbound and outbound routes. NACL are a great way of blocking a specific IP at the subnet level, especially yeah, hackers related IP address if you have anything, or unauthenticated IP address if you have anything, where we define in the NACL level to block it at a net before entering into that network itself with a deny rule. Yeah, NACLs are allowing that allow and deny, but security group by default that is denied, but yes, you can define allow rule. But we don't have the control on the security group level deny rule. Yeah, finally, if you conclude the difference between network ACLs and security groups, a security group at instance level, and this is at networking level, subnet level, NACL. And security group allows, it supports only allow rule, but NACL allow rules and as well as deny rules also we can define it. And security group is a stateful. Yes, written traffic is automatically allowed regardless of any rules. Yes, written traffic. Inbound, if you define that, automatically outbound is allowed. And NACLs is a stateless. Written traffic must be explicitly allowed by the rules. Yes, if you just define the inbound for the particular the IP address, if you define that inbound, you need to make sure that for the same thing, outbound rule also defined. Yeah, we evaluate all the rules before deciding whether to allow traffic. Yeah, so this is here we have this only defining that allow, there is no deny concept. And we process the rules in the number order when deciding whether to allow traffic or not. Yes, like as we're talking that same rule which has been defined for that inbound, then it is going to apply that on the base of the rule number, which is on the lower, lower number that will be given higher precedence. Yeah, it can be applied. The security group can be applied only instance if someone specifies the security group when launching that instance or associate the security group with the instance later on. Yeah, you can what is this applies to an instance only if someone specifies the security group and launching the instance, yes, or it can be associated later also. And whatever the NACL is automatically applies to all instances in the subnets it's associated with. Therefore, you don't have to rely on users to specify the security group. Yeah, by default, NACL that will be applied to the subnets, whatever we are creating that automatically. But if you have this any explicitly, you can configure. Yeah, so that's about some important points, understanding the difference between NACL and a security group. Yeah, so is it clear about that? So understanding the networking level. So NACLs and security groups. Yeah, good. Now, if you move into this next concept, that is monitoring. It's one more another important concept from the AWS which we should know. So far, if you just overall conclude that, so once once IAM account has been created, so how do we use it? The users creation, groups management, and policies management, roles options. Yeah, the IAM concept which we had it. And then once that's the IAM understood, then we were going through that as one of the important main resource, that is EC2 instance. Yeah, EC2, the managing with different launching methods, launching types, and as well as the defining load balancers for it, and as well as group specification, that is auto scaling group, and launching that instance with the templates, that is using the launch template with auto scaling group rules, then attaching that auto scaling group with the load balancer, and load balancer with the route 53, that is a domain mapping. Yeah, so there are the points that we were understanding, that is about the route 53 to that load balancer to the auto scaling group, within that auto scaling group the EC2 instances, and that EC2 instance, how do we map into the backend databases? That is RDS, another concept. And after that RDS, yes, we are saying that keep on taking the backups, but backups, where do we manage it? That is which we had about that S3 service. Yeah, application static data, if you have, or backups archive files, if you have, yes, we can store it in S3 buckets. And in that S3, yes, securities, you can define it at encryptions options or decryption options, and then and defining about the policies, and defining about that ACLs, access control list, and the rules. Yeah, that's we had it with S3. Then finally, but all these resources, whenever we are creating, is how do we go ahead with the public subnets and private subnets? Yes, networks, how do we define it and how do we manage into that? Yeah, these are all the so far, if you just try to understand it, how do we create a resources within the AWS, some important services which we are trying to understand it. But creating a resources, that is one thing, but those are all up and running it or not, or in case that service is down, that is instance is down, or RDS service is having the some limitation on the connections wise, then how do we get that the notifications? Yeah, monitoring about those resources is one of the very, very important concept. Yeah, creation process is one thing, but after having that all the resources, but how do you are going to monitoring about all those resources? Yeah, monitoring is very, very important. Yes, we know that how do we launch the instances, or how do we group it that instances with auto scaling group? Yeah, the safely, that is security point of view, and automatically we didn't discuss, we'll come back, that is in the next terraform we are going to talk it. Yeah, that is infrastructure as a code, we'll come back to that. Yeah, we know about it. How do we launch the resources in AWS? But once the instances have been launched or deployed, and about our users don't care about it, how we did it, right? The background, how we are managing that instances, the end users, they don't care about it. Suppose RiseNation now, we have launched or it is running on this AWS. But where it is running or how it has been deployed, you don't care about it that. But whenever you are trying to access about that application, is it available or not? That is about our agenda as a client point of view. Yeah, users only care that the application is it working or not. Yeah, how you are managing that internally, all these resources, that like they don't care about it. Yes, they look into about that whenever they are accessing this application, as application performance and application is it available or not. That is the client side they look into about it. Yeah, application latency. Yeah, this is very important to the user. Yes, whenever they are accessing this application loading time, it will be very good. We should not see this loading, and after that, sometimes it is loading. If you have that kind of, yes, so definitely the users they will get frustration, right, to use that application. And we should not see that application outages. Yeah, so like whenever we are trying to access this applications on XYZ, and if that XYZ application is not available because of maybe some crashes which are happen in the background, so customer experience should not, yeah, the customer experience will be degraded if we see those like outages. So we should not see that the outages from that application, and application performance should be very good. And yeah, users contacting that IT department or complying is not a good outcome, right? So application is, suppose if the application is down, yes, like the customers contacting to the support team, IT support team or IT department, and complaining about that application is not at all good. That is not good outcome. Yeah, so troubleshooting that application is very important. Undertaking that like the immediate actions. That is, yes, in case that application is a failed, the failed expected, but failed one, how or what is the time you are taking about it? Recovery of the time is very the important as a remediation. Yeah, these are all some points which we should consider that the whenever we are host yeah, whenever we are hosting that application to the customers, they should not see the latency issues, and they should not see that like errors from that application. And yes, users contacting, and these are all the errors which I'm facing, and reporting this to that IT department team or support teams. That is not good, the outcome. Yeah, so we need to have the internal monitoring. That means before going to intimate that issue information by the client, we should able to identify the errors before that's I mean, yeah, the before getting impacting to that client. Yes. So internal monitoring is required. So can we prevent issues before they happen? Yeah, if we're able to prevent that before going to happen this, the failure, then we are happy with that. Yes, we should have that mechanism. And performance and cost and the trends, that is a scaling patterns. Yes, what is the load that's we have that is in the peak hours, non-peak hours. Identification is very important. How the load we have this on the application. Yeah, trends keep on collecting that information. That is scaling patterns. And learning all these points and keep on improving that on the the site. Yes, application resources point of view. The internal monitoring is required. So whenever we talked about the monitoring of all the AWS resources, so what is the service that is helping this is AWS is providing the CloudWatch, so which helps about it collecting the metrics and tracking those metrics. Yeah, metrics. So that is, if you just observe that in the EC2 instance we have the monitoring tab, and in the RDS, yes, we have the monitoring tab. Or if you go to that, yes, auto scaling group, yes, we have the monitoring tab. Yes, in this monitoring tab, if we just observe that like load balance level, we have the 4xx errors, 5xx errors. Or if you go to the EC2 instance, what is the CPU utilization? What is the current network in and the network out? So these are all the metrics. So the metrics that is collecting and tracking that, all the metrics are the very, very important. And as well as the logs also. Yeah, suppose in the EC2 instance or in the RDS instance, we are observing that the logs. Yeah, EC2 instance where we didn't talk it, especially the logs, but RDS point of view, yes, we are talking that the logs, error logs, or transaction logs. Yeah, collecting those logs and monitoring and analyzing and storing the logs in the backup. Yes, those are all very, very important. So logs, if you talk it, that is a troubleshooting. That means some errors have been identified. Yes, how do we get the errors information? And once if you know the error, how do we take that action? That is a later story. But first of all, how do you know that the errors? That is logs are going to play important role. Yes, troubleshooting if we just talk it, logs, and performance if we just talk it, that is a metrics. Performance is the load on that application or services is which we need to keep on collecting those metrics, and peak hours how it is behaving, that the system resources that's utilization, and non-peak hours how it is behaving, that yes, analyzing that data is very, very important. And another concept which we have this is events. Yes, sending the notification whenever the certain events happen in our AWS. Suppose you had defined that auto scaling group. So some metric has been reached and instance has been added. Instance has been added is nothing but immediately we get that instance notification. Yeah, in the auto scaling group, so and so the rule has been reached, and because of that rule, the new instance has been launched. We need to have the notification system. Yeah, events. Events, if you just talk it, this is not only just sending the notification. Maybe you need to call it other services on the base of, suppose in the S3, some files have been uploaded. Yes, if the files the update is happened in the bucket or something, then we need to trigger another event, that is calling that lambda functions, or calling about sending the email notification, or triggering that other service, or scheduling a jobs. That all comes under events. Yes, this is one important concept in the CloudWatch. And another concept which others is alarms. Yeah, react in a real time to metrics or events. As we are talking that in the auto scaling group, particular CPU utilization has been reached the 70%. Yes, 70% is the CPU utilization of the 70% is a metric. But what do you want to do that whenever that metric is reached? Okay, in the auto scaling group, do you want to launch one more instance? That is a alarm has to be triggered. Yes, CPU utilization has reached the 70% is nothing but yes, some alarm has to be triggered to perform that particular event. Yeah, event is either sending the notification or calling that other services. Yeah, these are all the four concepts which we should understand from the CloudWatch. Yeah, metrics, logs, events, and alarms. But what about these metrics and what are the different metrics are available? Yeah, if you try to understand this, that's metrics point of view. Yeah, first let me show that, yes, where do we have the CloudWatch service and how do we access the CloudWatch service? Yeah, so this is a CloudWatch, the service, monitoring the resources and applications. And this service is that is a region scope, which region you are working, that region based, yeah, that will be applied. And as we're talking about it, the four concepts. So one is the which we are talking about it. Yeah, metrics are displaying in the dashboard, or you can see this metrics, yes, separate section metrics, and these metrics normally we display in the dashboard. Which will come back. This is the first section. Then using these metrics, then we can go for the creating alarms. Yeah, you are creating that alarm is nothing but that is the dependence on the metric, CPU utilization, or network in, or network out, or auto scaling group. Yes, group wise, the rules which we are talking about it are policies. Yeah, metrics which you can use it to display in the dashboard, or metrics which we can use it as an input to define the alarms. Yeah, next another concept which we're talking that events. Events is we can do that. There are the scheduler based events, or in the particular service, suppose instance is down, or instance has been stopped, then we need to get that like a email notification. Yeah, that is how do we manage it about those kind of the activities is that is the events is the concept which is available. Next another concept which are this is logs. Yeah, collecting the logs from the EC2 instances or collecting the logs from the RDS instances and storing into the S3. Why do we need that? Yes, clearly analyzing about it, all the messages or the transactions which are happening within that EC2 instance or within that RDS. Yeah, we can create a log groups and we can collect that all the logs files information and we can analyze it with the insights. Insights is kind of, yeah, it is also kind of the dashboard where all the logs you can apply with the queries and you can get that, the filter options. Yeah, there are the four important sections in the CloudWatch which we should understand. That's about, yeah, the metrics is the first point. And metrics, once you identify it, yes, you see this all the metrics the which we can get it. Yes, almost 438 metrics are available in this Mumbai region. Yes, on the base of the services which you are using, then you will get it all these metrics. Yeah, EC2 related metrics, EBS volume related metrics, logs related metrics, NAT gateway related metrics, S3 related metrics, RDS engine related metrics. Yeah, on the base of the services which you are going to creating that for that service related metrics that will be added in the CloudWatch. And these metrics, suppose, yes, you can identify that EC2 metrics or EBS volume metrics or RDS, which one is required. Yes, you can identify that and you can create a graph for it. And these graphs we can add into the dashboard. That's how to create it. That's we'll come back to that. Yeah. So the metrics is the first, the main, the input. And using this metrics, you can create a graphs and these graphs you can add into the dashboard. And once these metrics are available, yes, if you are creating that alarm is also having the dependency on the metrics. Yeah, so these are all things. This main concept which we should understand, 4 concepts in the CloudWatch. Yeah, the metrics which you can identify, and you can create a graphs and you can add to the dashboard, and you can identify the metrics, and if the metric is something is happened, then you can trigger that alarms, and you can create like events. Yes, if some service related action is performed, then you can trigger that event. And finally, you can get it all the logs of the EC2 instance or VPCs or RDS instances, and you can analyze it all the logs in this CloudWatch section itself. Yeah, that's about the CloudWatch, very important service. And we started tomorrow about it, understanding this. The first, what about these metrics, and how do we use these metrics to create a dashboards, and then how do we use that metrics to create alarms. Yes, we'll start it tomorrow on it. Maybe that's required the 2 days sections for this, tomorrow and the day after tomorrow. And when this is done, another concept which is available, that is AWS CLI. Yeah, command line interface. Yes, that's AWS CLI. How do we use it and how do you do that? And the command line interface to manage it, these resources. So one that is done, then we move to that Terraform, that is infrastructure as a code point of view. Yeah, so that's about for today. Just getting that the concepts on the VPC about NACL and security groups. And yeah, once the services have been created, services monitoring, services related data collection, and on the base of the data, defining the rules. And if some rule is reached, yes, performing that alarms or the events, that is another important activity. Yeah, we'll start it tomorrow about it. So this CloudWatch, the first metrics with the dashboard, and then metrics with alarms. Then we'll continue with the events and the logs. Yeah, that's all from my side for today. Any queries, questions, please? Yeah, okay. So cool. So that's all. We'll meet tomorrow and we'll continue. Yeah, thank you. Thank you all.